Okay, this is mixed exercise 4F from the core book. Question number 1, there's a line y equals 2x minus 8, meets the coordinate axes at A and B. So this is a classic example of a problem where a diagram will help, and it won't be that hard to get the diagram going. The y-intercept of that must be -8, because that's what you get when you put x equals 0 in. So that's the y-intercept. And the x-intercept, when you put y equals 0, you get x equals negative, so you get x equals 4. So that's my diagram. We've been told that we've been given names for the points where it intersects. It doesn't matter whether it's AB or BA, but we are told that this is the diameter of a circle, which means the midpoint of this join must be the center. We have a formula for midpoint. It's the x coordinates added up and divided by 2, and the y coordinates added up and divided by 2. So this center here, the center of the circle, must be 2, -4. That's the center of the circle. I don't have a compass with me. It's pretty bad, but anyway, that's my circle roughly. Now, we have to find the equation of the circle. Equations of a circle have this as a template. All you have to do is put in the A and the B. They come from the center, and the R is the radius. So the center we've already identified. And now we just need the radius. The radius would be half the distance from there to there. You can always use Pythagoras to work out a different distance, but in coordinate geometry you've got a formula. This is it. That's the distance between 2 points. So for us, that's 4 take away 0 plus 0 take away -8. And that amounts to so this is the distance A to B, and that amounts to, so I'm just labeling this properly, that's the midpoint. So that amounts to 16 plus 64, so the square root of 80. But we want half of that, so the radius is half of the square root of 80. So therefore our final equation of the circle, tidying this up, is half the square root of 80 all squared, and here's my final tidying. So square that, you get 80, square that, you get 4, so that's the equation of the circle. Question number 2. We've got a circle, center 8, 10. I really don't see that I'll be doing any of these problems without a diagram. That's 8. So that's the center of a circle. It meets the x-axis at 4, 0, and that's been called, doesn't have a name, but that's where it meets the x-axis. And it meets the x-axis again at A, 0. Well, if that's the center of the circle, and I had a compass, I could just set that to be the radius and swing that around there. I think that's the only way it can hit the I think that's the only way that it can hit the x-axis again. Now, we have to find the radius of the circle. Okay, well that's just the distance from there to there. Distance form will do that for us. The subtraction of the x coordinates plus the subtraction of the y coordinates added together and squared. That's the distance. Which is 116 square rooted. So that's the radius, and we need to find the value of a. Okay. Well, there is a famous circle geometry theorem which says that whenever you have a chord and you build a triangle like this, and as long as that's the center, and as long as that's a right angle, then you can be sure that that distance matches that distance. Basically it's saying that there are two things that cannot happen without the third. The three things are that being the center, that being the same as that, and that being a right angle. If you know two of them are the case, then the third must fall into place as well. Now, therefore, if I drop that down vertically, that will definitely be 8, 0. Because that's the center, and I just drop that down vertically to make that a right angle, this distance has to be the same as that distance. So that's a distance of 4, so that has to be a distance of 4, so therefore A must be 12. And the circle theorem I'm using there is perpendicular bisector of a chord goes through the center. Now the reason why I used that theorem is because it was just so easy to drop this perpendicular and be sure what that coordinate was going to be, because it was directly below it. If that hadn't been the case, there's another way of solving this problem, and that way is just to find the equation of the circle and then find the x coordinates, find the x-intercepts of the coordinates of that circle. I'll just demonstrate that. Here's the equation of the circle. There's the center, 8, 10. So that's slotted into the template. Remember, the template is this. The radius we worked out was square root of 116. And so now all you have to do is find the x-intercepts of that. The x-intercepts come from y equals 0. So I'm just solving this quadratic now. So I don't know what happened there. 16, which means that's 4 or negative 4. So therefore x equals 12 or x equals 4. The x equals 4 we already had, and there's the x equals 12, which is the conclusion I already came to. So just so it's clear, this is another way. This is the algebraic way. This is the geometric way. Geometric way is arguably quicker. You just have to be very careful that you're using that theorem in the right way, and not just relying on the look of your diagram. But if you can be sure that your diagram is not misleading you, then these little circle theorems are the absolute business, and you can get a question in very, very, very quickly. All you have to do to make sure you get the marks is to state the reason. And the reason I was using there is that when you have a diagram like this, you can't have two or three things without the third. If I tell you that's the center, if I make a triangle like this, if I tell you that's the center, and I drop down there, if I tell you that's the center and I tell you that's equal to that, that must be a right angle. If I tell you that's the center and I tell you that's a right angle, that must be equal to that. If I tell you that that's equal to that and that's a right angle, then you can be sure that that's the center. In other words, you can't have two of the three things without the third. The three things are the fact that it's perpendicular, the fact that it's a bisector, and it going through the center. Okay, question number 3 is a quick little one. This is a rare example where I don't think I need a diagram. I'm given the equation of a circle. It meets the x-axis at P and Q, and I've been asked to find the coordinates of P and Q. Meeting the x-axis, that is a classic x-intercept. You get x-intercepts by making y equal to 0. So x equals a 11, or x equals -1. For goodness sake, don't forget to answer the question. Just because you've done the hard work doesn't mean you're done. Remember what I was asked. I was asked for actual coordinates. So the actual coordinates are P equals 11, 0 and Q equals -1, 0. So that's a rare example of a coordinate geometry question which can be done safely without a diagram. Question number 4. Question number 4 is the same, pretty much. We've been told it meets the y-axis this time at 0, m and 0, n. We've been asked to find the value of m and n. This is a x-intercept. Sorry, this is a y-intercept question. In fact, the fact that x is 0 always goes with the y-intercept anyway, but here x being 0 is laid out for us bare in front of the commas. So the question reduces to this. It's 121, that's 16. I think it's 105, I think. So y minus 7 equals the square root of 105, or y minus 7 equals negative the square root of 105. So y equals 7 plus the square root of 105, or y equals 7 minus the square root of 105. So one of them is your m, and one of those is your n. Now, I should just point out that I'm always telling people not to use the same letter to refer to two different things, so I'm just going to delete that. M is this, and n equals that. They're clearly different, so don't use y for both of them. Of course, when you're in the course of solving the problem, you can say y is this, y equals that, because there's two possibilities for y. That's why we use the word or. But when we're actually presenting the solution, we don't need to call them y anymore. We don't need to use the word or. We've just got an answer for m and an answer for n, labelled with two different names because they're two different numbers. Okay, question number 5. Okay, y equals 0, that's the x-axis. It's a tangent to this circle, most of the details of which we know. We know that its radius is 4. because the template for the equation of a circle is this. What's playing the role of r squared? 16, so r must be 4. What's playing the role of a? 8, so our circle is 8, comma, mystery. So that should be y minus b. So the center is 8, comma, mystery a, which annoyingly has been given the same letter as that. So I'll just fix that. And the radius is 4. Okay. Now that's probably enough to draw a diagram, even though there's this mystery value. Not knowing all the details is never an excuse for at least thinking about doing a diagram. We know it's 8. We don't know how high it is, but we know that the radius is 4. When a tangent meets a radius, it's always at a right angle, so we can be sure that the center of this circle, and all I'm doing is thinking about drawing a nice non-misleading diagram at the moment. Slightly embarrassingly, I haven't even read the question. Yeah, I have to find A. Yeah, I'm just drawing the diagram at the moment. The x-axis is a tangent, so we must make a radius meet the tangent at a right angle. So therefore, there's a radius of 4. There's another radius of 4. So it's one circle. Sorry, I don't have a compass. That's another possibility. And so therefore the center of the circle is either 8, 4, where the radius goes 4 up above the tangent. Remember, this is the tangent, and that's my right angles. Or it could go 4 below the tangent. So therefore A equals 4 or -4.